Hi guys, we're going to do some integration with bounds with these little guys right here, this number 2 and this number 10 here. Okay, so we're not going to have to add that constant c anymore. We're actually going to find the antiderivative of this function here, the 1/2 x plus 4. And whatever we get, let's just call it capital F of x. Okay, so it's going to be some function here. And what you're going to do when you get that function is you're basically going to substitute 10 into the function, and then you're going to substitute 2 into that function, and you're going to take the difference between those. Okay, it's very important that the number at the top is what goes in first, and then the number at the bottom is what goes in second. All right, so this is how you find the area under the curve. Okay, and we can actually find the area under the curve right now because this is just a linear graph, 1/2 x plus 4. We can find the area under that curve using simple geometry. In fact, let's do that, and then we'll actually take the integral and show you that when we substitute the 10 and the 2 in, and then we take the difference, that we get the same answer. All right, so it's pretty cool like that. All right, so if we were to graph this function, we'd have an x-intercept of 4, and at 2, we'd be at 5, right? You just substitute in 3, 4, 5, 6, 7, 8, 9, 10. And at the point 10, we would be up at 9, 5, 6, 7, 8, 5. All right, so this is just my sketch. Okay, and what they're asking us is to look in between 2 and 10 here and find that area. Okay, because remember that integral says find the area under the curve between those two values, between 2 and 10. Okay, so this is basically 10, 9. Sorry if my sketch is a little bit hard to follow, and this is the 0.25. Okay, so 2, 5. All right, so this just looks like a basic trapezoid. So the area of a trapezoid is just, if you remember, 1/2 base 1 plus base 2 times the height, right? And the bases are the parallel parts. So we've got a base of 5 here and another base of 9 over there. And then what is the height? The height is this guy. That's a difference of 8. So the area of the trapezoid here is going to be 1/2 times 5 plus 9 times 8. So we get half of 14, which is 7 times 8, which is 56 units. All right, so we get 56 here. All right, so now when we actually go do the integration, we'll actually see that integration gives us that same area under the curve. All right, so I'm going to erase this guy, and we're just going to integrate. Okay, so we have a power of 1, not -1, so I'm good to add add 1 to the power. So I get x squared over 2. All right, and I have that 1/2 constant out in the front here. Okay, and then plus 4x, right? The derivative of 4x is 4. And I do not need to add that constant anymore. So I have x squared over 4 plus 4x. This is our big function, f of x, okay? And so we're going to do f of 10 minus f of 2. All right, so f of 10 is basically 10 squared over 4 plus 4 times 10. That's our f of 10. And we're going to minus f of 2, which is 2 squared over 4 plus 4 times 2. All right, and so this is basically 100 over 4, which is 25. 25 plus 40 is 65, right? And then we're going to subtract, this becomes 4 over 4, which is 1, 1 plus 8, which is 9, and 65 minus 9 is 56, just like we said it was going to be over there. Okay, this wasn't just some accident because it was a linear function. I just picked a linear function to show you that, in fact, we do get the area under the curve. Okay, so whenever you have these bounds here, you just take the antiderivative and then you substitute in the upper bound and you substitute in the lower bound, into your antiderivative and you take the difference, okay? Even if the smaller number is your upper bound, like if it was going from 10 to 2, your answer would be negative, which would mean that your area would have been under the curve somewhere. So we're not going to get into that. I'm sorry, yeah, under the x-axis. Okay, so if you have a negative area, it's just the area under the x-axis. See how this area was above the x-axis? That's why we have a positive area there. Okay, so that should help you understand the next example in the homework.